right, a tank of water in the shape of a cone is leaking water at a constant rate of 2 feet cubed per hour. The base radius of the tank is 5 feet, and the height is 14 feet. So what this looks like is a cone that is circular at the top, and the radius of this cone is 5 feet. So 5 feet, and the height is 14 feet. All right. It says, at what rate is the depth of the water in the tank changing when the water is at 6 feet? And then part B says, at what rate is the radius of the top of the water in the tank changing when the depth of the water is at 6 feet? Okay, any questions? Stephen? All right, so I've drawn this cone, and I've written down some of the things that we need to know. All right, one thing that I didn't write down, and I don't remember what the answer is, it's leaking from the tip of it at what rate?
There, 2 feet cubed per hour.
Okay, 2 feet cubed per hour. Feet cubed is what kind of a unit? Three-dimensional. It's what? Volume. Okay, and hours is time. So it tells you that this is actually dV dt, the volume, the change in volume with respect to time. All right. Does anybody remember the formula for a three-dimensional cone, the volume? Yep, it was one of the first ones we did.
It's got pi.
The V equals 1/3 pi r squared h.
Good. Pi r squared times h. Okay, so I want to walk through this problem a little bit. It's going to take me a minute to kind of get to where we're going. So instead of writing all this down, why don't you just watch what I'm doing? Okay, so here's how we're going to do this. We always want to take the derivative first. All right. They are asking for dH dt in part A and dR dt in part B. So if I take the derivative of this with respect to time, I get dV dt is equal to pi over 3, and then these are multiplied together. So I have to do what?
Product rule.
Product rule. So this is 2r dr dt plus, times h, plus r squared times 1 dH dt. All right, so dV dt is equal to pi thirds times 2rh dr dt plus r squared dH dt. Okay, so at this point, if I go to plug in what I know, I've got h, but I don't have r, but I could find r pretty easily, yes? How would I find r? Okay, so maybe it's not as easy as I said, okay, and it's not. All right, if I did have r though, I don't have dr dt, but it's one of the things I'm looking for. I don't have dH dt either, but it's also one of the things I'm looking for. So at this point, I have 3 equations, and 3 unknowns and 1 equation. I can't work that problem like that, okay? So whenever I have these 2 variables and they don't give me all of the information, you kind of have to take stock. What do I have, and what do I need, what do I don't have? So here's what we need to do. We need to come up with another equation that relates r to h. And what we're going to do is we're going to create a triangle. Okay, so we're creating a triangle right here. This triangle has a height of 14, and then this base is 5. All right, and when it's full, that's where I can get my volume through this formula. But when it's not full, say water is just to right here, now I have another triangle that's dealing with that. What can you say about those two triangles?
They're, is it not the word for it's like proportional?
Okay, they're proportional, they are, and they're proportional because that angle is the same for both of them. This angle right here and this angle right here are the same for both of them, and then this angle is a 90-degree angle. So since they have all the same angles, they're called similar triangles. So I want to create similar triangle, and you said the word proportion. Okay, and so what that's going to look like is the overall triangle. So we'll put h on top. So this is 14 over 5. So that's h over r. Y'all agree with that? H over r. And so what I'm going to do is, using this relationship, I'm going to eliminate one of our variables. All right, and it asks for dh dt first, so I need to eliminate r if I'm going to solve for dh dt. So what I'm going to do is I'm going to rearrange this so that I have r is equal to something in terms of h. And the way that's going to work is I'm going to multiply both sides by r, which gives me 14/5 r is equal to h. And then I'm going to say r is equal to 5 over 14 h. Okay? Okay, now what I'm going to do is I'm going to go up to my original. Okay, I ask you not to write this down because all I did was expose a problem that we have in it. Okay, so now I'm going to go back up to here, and I'm going to say v is equal to pi over 3 times r squared, which is 5 over 14 h, all of that squared times h. Okay, so this is 25 pi over 14 squared is 196 times 3 is 588 times what? H squared times h is cubed. Okay, now I'm going to take the derivative. And this turns into dv dt is equal to 25 pi over 588 times 3h squared dh dt. Everybody agree with what I just did?
I'm not sure I do last one. That's just a product rule you use?
I just did the regular derivative with respect to t. So 3, this exponent comes down here, times h to the 3 minus 2, or 3 minus 1 is equal to 2, times dh dt.
Why? Is that derivative that you have to put with respect
To t. That's right. It's all with respect to time.
and that's only the first part, right?
Okay, well at this point we plug in what we know. It's leaving at 2 feet. So this is negative 2 is equal to 25 pi 588 times 3 h. They tell me h, right? It's 6 squared, which is 36 dh dt. And now can I solve for dh dt?
Yes.
So 2 times 588 divided by 3 divided by 36 divided by 25 divided by pi, I get dh dt is equal to negative 0.14 feet per hour. Okay? So I had to use another equation. I had to come up with it to find that relationship. When you have more than one variable, that happens a lot. Okay, so triangles work nice, but if they don't give me dx dt and dy dt, I have a problem, right? Here they didn't give me dh dt or dr dt. So I had to find a solution to that, and I found that solution with a similar triangle. You have a problem like this. I've worked two problems like this now. One on your first set of notes, and now this one.
How do you identify what you take the derivative of when we're in this equation?
This?
The one we just did. Like, I would assume that you use the product rule because you're multiplying 25 pi over 588 times.
Well, but this is all constants, right? So this is just a number.
So that just means that you just leave it alone.
Yeah, it's because what does a constant do? If I did do the product rule, I would take this, which is a number, times the derivative of this, plus this times the derivative of this. And what's the derivative of that? What's the derivative of a constant? 0. So it goes away. So that's why we can use the power rule
Okay.
on that one. Okay? All right, good question.